Welcome to the last video of section 8.3. We want to find a power series solution only up to degree 3 for this differential equation here. So we start like we always do, n equals 0 to infinity cn x to the n. Y prime is going to be the sum 1 equals n to infinity of n cn x to the n minus 1. And then finally, y double prime, 2 to infinity, n times n minus 1, cn x to the n minus 2. We plug those values into our differential equation to get n equals 2 to infinity of n minus 1, cn x to the n minus 2, plus parentheses x minus 1 all times y prime, which is the sum n equal 1 to infinity of n cn x to the n minus 1, and then plus y, which is n equals 0 to infinity cn x to the n equals 0. Fortunately, you can slow this video down or speed it up. You're probably slowing it down at this point. Distribute. There's nothing to do for the first guy and the third guy, but this middle one is going to actually give me two power series because I need to distribute the x and then distribute the negative 1. So I'm going to have 4 power series on the next line. So write small. N equal 2 to infinity n minus 1 cn x to the n minus 2. Then when I distribute the x, I get n equal 1 to infinity n cn, and my exponent of x will be x to the n because I'm adding n minus 1 to 1. Now I distribute the minus 1. Well, actually, I'm going to put a minus there and distribute the 1. So 1 to infinity, just copy it down again, n cn x to the n minus 1. And then the last guy is plus n equals 0 to infinity of cn x to the n, and then don't forget your equal 0. Reindex. So I need to reindex the first and the third. The second and the fourth are already in terms of x to the n. So the first guy, sorry about that, the first guy is going to start at 0, and it'll be n plus 2, n plus 1, cn plus 2, x to the n. Leave the second one alone, 1 to infinity of n cn x to the n. The third one, I need to add 1 to the exponent, so I'm going to subtract 1 down here at the base, so that'll start at 0, and it'll be n plus 1 cn plus 1 x to the n. And then the fourth one I can just leave alone. And that equals 0. Combine. So my highest value of n there is n equal 1, so I need to start them all at 1. So that means I need to pull out the 0 term from this guy, and this guy. That gives me 2c2 minus, don't forget the minus, c1, and then plus c0. So that's my constant term. And then I've got a single power series, which I start at 1. I combine all 4 coefficients. So here we go. The first one's going to be n plus 2, n plus 1, cn plus 2. Then I'm going to write down my cn plus 1 term because there's only a single cn plus 1. So minus n plus 1 cn plus 1. Now I'm going to write down the coefficients from the second and the third. I have ncn, we'll do it over here, I have ncn plus cn. So that last one's going to be plus n plus 1 cn You don't want two CNs there, so combine them. N plus 1 times Cn. Then we'll close our bracket, x to the n equals 0. So if you need to, pause the video and make sure you can understand that step. Okay, now we're going to set all coefficients equal to 0. So again, don't set each individual piece here equal to 0. Set the whole thing equal to 0 and solve, which I did right here, and solve for the highest value of c. So that's C2. And that's going to give me C2 is, bring the C1 over. So 1/2 C1 minus 1/2 C0. So that's one thing I'm going to need. And then set this giant thing equal to 0, which I did right here. And that's going to give me, yikes, Cn plus 2 is, I'm going to bring this guy over, so n plus 1 Cn plus 1 minus n plus 1 Cn, all divided by n plus 2 n plus 1. Now I can factor an n plus 1 out of the top, and when I do that, I can cancel it with the n plus 1 in the bottom. So I'm going to get Cn plus 2 is Cn plus 1 minus Cn over n plus 2. And that's valid for, I look to see where the summation starts. It starts at 1. So n equal 1, 2, dot, dot, dot. All right, I only have to find up to degree. So this is a little more complex than our previous recurrence relations in that Cn plus 2 is written in terms of 2 of the other Cn's instead of just 1 of the other Cn's. But that's okay, we can work with it. Fortunately, we only have to find up to C3 because it's going to take a while to find C4. So when I set n equal 1, I'll get C3. So I'm looking at this guy right here. And that gives me C3 is C2 minus C1 over 3, which is 1/3 C2 minus 1/3 C1. But I'm only allowed to write this in terms of C0s and C1s. So I can replace the C2 with what's in the circle up here. C2 is 1/2 C1 minus 1/2 C0. Okay, and then minus 1/3 C1. Okay, so I can clean that up. That's 1/6 C1 minus 1/6 C0 minus 1/3 C1. A sixth take away a third is negative 1/6, so I get negative 1/6 C1 minus 1/6 C0. And I'm done. Okay, write down the first several terms of y. I really only need to go up to 3 because I only want the first, I only want terms up to degree 3, but I was copying and pasting and I had it up to degree 5, so I left it like that. So plug in. So y equals C0, nothing to plug in there, C1x, nothing to plug in, C2, so go up here, what was C2? C2 is 1/2 C1 minus 1/2 C0. I've already forgotten what I said. 1/2 C1 minus 1/2 C0. And that's times x squared. And then my C3 is negative 1/6 C1 minus 1/6 C0 x cubed plus dot, dot, dot. Okay, now I'm going to separate out the C0 terms and the C1 terms. So C naught 1 minus 1/2 x squared, and then I got a C naught term over here, minus 1/6 x cubed, plus dot dot dot. Then I got my C1 terms. I've got x, and then here, when I distribute, I'll get plus 1/2 x squared, and then I've got over here minus 1/6 x cubed, plus dot dot dot, and that's it. So on this step, you could have separated out, distributed, and then gone to your last step, but you can just do it mentally. Just pluck off the parts of this that involve a C naught, and then pluck off the parts that involve a C1. And that's the end.